Perhaps there is nothing so mysterious or complex than cloud-native concepts in wireless telecom. As an industry, we're undergoing a profound digital transformation that will give us the ability to provide exabytes of hyperscale data that is locally relevant. The collision of cloud IT and wireless has been happening at the same time. As a father of 2 teenagers, let me tell you, it's a lot like growing up. I can identify and remember the challenges during those awkward teenage years. The wireless industry is moving from 4G to 5G, and it does involve cloudification. And just like those awkward teenagers, we're grappling with some of those growing pains. So what's all this cloud talk about? Well, let's cover a few concepts: containerization, microservices, DevOps, the control and user plane separation, service mesh, and the continuous everything. Think about your computer. Inside is a CPU, a graphics card, RAM, a hard drive, etc., etc. Now imagine you had 10,000 PCs. It would logically make sense to put like together with like. 10,000 sticks of RAM together, 10,000 graphics cards together, and so forth. Certain tasks will require different types and amounts of resources. For instance, if I wanted to render a motion picture in full 8K, it would require much more graphics-intensive computing than, say, if I wanted to send out 1 million text messages. So, I would package up just the right amount of GPUs, CPUs, RAM, and storage that I need in some kind of container. That's containerization. When you do that at scale, you can achieve amazing results. Do you ever wonder how many features and functions something like the Uber mobile app must put together? There's a map, a driver database, rider database, vehicle information, billing, price quoting, driver quoting, customer service engine, recommendation engine, all kinds of stuff under the hood. Each one of those features in itself is a microservice, and each microservice calls upon different resources from the cloud. Our digital world is rapidly changing. The new world is now one of continuous upgrades and enhancements where DevOps teams scale, monitor, improve, ensure reliability, and ship code faster than ever before. You're no longer on product launch cycles, you're on upgrade cycles. DevOps provides organizations with a much more fluid, agile approach for providing customers what they need. If the old digital world was like the Army, then DevOps is like special forces. It's been said before that software is transforming the world. To a certain degree, that may be true. In 2007, Apple changed the wireless world with the introduction of the iPhone, to which many scoffed at the fact that there was no keyboard. It was simply a glass surface with a single home button, and all the smartphone's major features became simply digital applications. This is what is happening in the wireless industry today. We are undergoing the start of a massive digital transformation that is creating a separation between the control plane and user plane for the management of data. The functionality of a piece of equipment is becoming separated from the actual underlying hardware and replaced with digital software on top. These ideas are what form the basis of network function virtualization and software-defined networking. With all these interdependent containers and microservices running together, how do you keep your world straight? What happens if one of your containers is running one kind of machine and the others on another kind of machine? How do you ensure that they can talk? That's where Service Mesh comes in. A service mesh is simply a platform or infrastructure layer that allows for the orchestration, management, and automation of all these component parts. Service meshes allow for containers and services to talk to each other via their APIs, regardless of where they're located or what kind of architectures they're based on. Think of it as a kind of universal language translator that keeps things chugging along. Therefore, service meshes are said to be abstract and cloud agnostic. Moving to cloud native does lead to increased agility and complexity. But if everything is done right, then continuous integration of all these containers should eventually lead to the ability to provide a seamless, continuous delivery, similar to what 5G Americas talked about in the previous Management, Orchestration, and Automation white paper. Looking at it from a network operator's perspective, we have key areas to focus on, specifically firewall, routing, deep packet inspection, and charging and data store. Each are key features of the modern wireless network. Network operators are rightly concerned. They need to keep the lights on. They must ensure that the software code is properly versioned and configured. Data caches and messaging queues are integrated, application processes are organized, and development and production of new services don't disrupt existing services. There could be platform shortcomings where data centers may not be up to speed, or new network challenges introduced by the introduction of new services and applications, or even an increase in some security risks. So 3GPP has created a reference architecture that is based on ETSI standards. It has been developed around the delivery of services to users, otherwise known as a service-based architecture, or SBA for short. Every operator has a unique opinion and is at a different level of maturity on the road to cloud native. Not every operator is the same, and they each have different strengths. If experience has taught me anything, it's that there are a lot of smart people working on our wireless networks today. The arc of progress always moves in the right direction to serve our customers and enterprises that rely on our wireless technology. I'm confident that these new changes towards cloud native are like my awkward teenagers. It's all going to lead to great things.